Now we're going to look at how we describe the center and variability for data distributions that are skewed or have outliers. So one of the problems with using the mean as a measure of center is that if the data is skewed or has outliers, the value of that mean is going to be greatly affected. We noticed how to calculate the mean, we had to add all the observations up. So every single value was included in the calculation for the mean. But when we look at the median, we're not going to do that. We're simply going to find the middle number. So let's look at how we would calculate the median. We're looking at data from 40 students who are enrolled in a statistical reasoning course at a California college. The instructor made course materials, grades, and lecture notes available to the students on a class website, and course management software kept track of how often each student accessed any of these web pages. So 1 month after the course began, the instructor requested a report on how many times each student had accessed a class web page. And the data that was returned looked like this. So we had some students who never accessed any of the pages, but most of the students were there between 0 and 25. We had one student who explored quite a bit and had 331 visits to the web page. So that one value being such an outlier is going to greatly distort our calculation of the mean. So we would not want to calculate the mean for this data set. Instead, we're going to calculate the median. So the way that you calculate a median is you find the middle value of the distribution. A way that you can remember that is the median strip of a highway is what divides a highway in half. And the median for numerical data set is going to be exactly the same. We do have two different rules based on the number of observations in our sample set. If n is odd, you're going to pick the exact middle value, but if n is even, you actually are going to average the two middle values. Unless your data set is really short, you would rarely do this by hand because it's just a lot of calculation that we have computers that can do this for us. But if we look at this sample with the 40 students and the web page clicks, we would see that there are 40 observations. So we would need to get the 20th and the 21st values in order to calculate the median. We take the 21st value and the 20th value and we find the average. In this case, they're both 13, so the average would still be 13. But if they were not the same, you would simply add them, divide by 2, and that's going to be your median. You can think of the median as the value that divides the data set in half, even if it's not actually one of the values in the distribution. Because the sample mean uses every value to do the calculations, it's going to be sensitive to a single outlier. But because the median is simply looking at the middle value, it's quite insensitive to outliers. Some distributions that are particularly known for having some very large outliers would be things like salaries in companies, where your CEO is going to get paid significantly more than most of the other workers, or housing prices, where occasionally there will be some very expensive homes, but most of the homes are going to be clustered at a much smaller value. So when you're looking at information about companies and housing, you definitely want to look for the median values because that's going to tell you a lot more about what you can expect to find versus using the mean that's going to include those really high values and make it look larger than the center value really should be.